Welcome to week 4 of creative engineering. Today we are going to talk about how engineers communicate, and we're going to look at how they use sketching and 3D modeling to engage in effective communication of their ideas. Every day we are communicating with many people. Even as we are in this time of quarantine, we're still connecting with people in many ways, and we communicate in many ways. Sometimes that's written, and sometimes that's spoken words, but not always. Sometimes we communicate through other things, maybe by the clothes we wear or the posture that we keep. Whenever communication is engaged in, it's important to use the correct materials and tools to have that communication work effectively. For example, if you decided to make a telephone call, you would have much more success using a cell phone rather than using a tin can and a string. And so I want to talk to you today about how engineers communicate their excellent ideas effectively so that people understand them well enough to be able to reproduce and build them. Before we begin, I want to talk about a couple of important vocabulary terms. I also want to remind you to go ahead and open your digital worksheet in Google Classroom if you have not already. There is a whole page at the beginning of your digital worksheet of vocabulary, and I thought it was very important to just provide you with a definition of each of the terms so that as you work with them in this lesson, you can understand. A couple that I want to mention before we jump into talking about sketching is the word scale. In this context, scale means keeping the same proportions when drawing something as larger or smaller than it really is. An example of scale is shown here in the Eiffel Tower. There is a picture of the full-size Eiffel Tower, and there is a sketch of the Eiffel Tower on a piece of paper that has been drawn to scale. It's exactly identical in every way to the Eiffel Tower, except that 1 centimeter on the sketch is equal to 36 meters on the actual Eiffel Tower. The second term I want to talk about is the dimension. The term dimension means the height, width, and depth measurements of a design or object. Whenever we're sketching and communicating through sketching, it's important to let the people looking at our sketches know what size an object or design is. Have you ever ordered something off of Amazon or maybe off of another website, and when it arrived it was much smaller or much larger than you expected it to be? This is why dimensions are important. It's an important piece of communicating. Engineers and designers communicate effectively using 2 things. First, they use sketches. Sketches can range from thumbnails, which are very basic, through isometric and MultiView sketches to 3D models. In addition to sketching, they also use annotations and dimensions. These are measurements, notes, process descriptions, and presentations which further expand on the sketches that they have provided. When used together, sketching and annotations and dimensions equals effective communication of ideas and design plans so that others can build them. The first type of sketch that engineers use is a thumbnail sketch. This is a simple perspective sketch that shows the basic shape and details of an object or design. You would use a thumbnail sketch at the brainstorming stage or at the develop a solution step of the design process. You simply sketch the best you can to show a general outline of what you might be designing. This helps other people give you feedback, and it helps you to express your ideas in a way that other people can visualize. Once you have created a thumbnail sketch and you're pretty sure of how you want to design something, you then can generate an isometric sketch, which is a 3D sketch that shows the top, front, and right side views in one drawing. It's built around the height, width, and depth lines, and an isometric sketch may contain dimensions It will definitely contain annotations that help us to understand how the object goes together. Here you can see an isometric sketch of a camera, and it shows a lot of very important details, including dimensions and the angles that certain parts are at. After you've generated an isometric sketch, and you can see here an isometric sketch of a puzzle piece in the upper right-hand corner, you can then use that sketch to generate multi-view sketches. Multi-view sketches are a series of 3 sketches of the top, front, and side view of an object. But these sketches are 2D, meaning that you draw them as if you were looking straight on them and only show one side. These sketches also are perfectly aligned with each other, and this is the best type of sketch to include dimensions on. These type of sketches are used in manufacturing and construction to help make sure that things are built to the correct size. The last type of sketching that we are going to talk about today is 3D solid shape modeling, and this is where we're going to spend the rest of our time. 3D solid shape modeling is a computer-generated 3D model of an object or a design. Whenever you are generating a 3D model, it has many advantages. First off, it's on the computer. Second, it's easy to sketch a 3D object. And third, you can include dimensions with that 3D object very simply. And it's oftentimes faster than hand sketching things. So 3D modeling has a wide range of options and a wide range of software programs as well. If you are interested in more design, such as architectural or engineering design, SketchUp or Autodesk Inventor are some really common programs that industry experts use all the time. If you're thinking that you'd like something a little more web-based, you can use Tinkercad, which is a super fun program, and it is the program we are going to learn to 3D model in today. Another awesome program that I've been learning how to do 3D modeling and animation in is Blender, and we're going to take a look in a moment at what Blender does, but you might recognize a lot of Blender 3D animation in Pixar films. So these are skills, 3D modeling skills that are used for entertainment and other types of things than simply engineering designs. Today, we are going to be learning to generate 3D models in Tinkercad. There are some simple steps for logging in that I'm going to go through in the video right now. If you need additional support for logging in, you can also find a link to a step-by-step printout of these steps in the digital worksheet. Step 1 is go to the Tinkercad website. So you will type in www.tinkercad.com into your Chrome browser window, and that will take you to the Tinkercad website. Step 2 is click the Sign In button. Please click Sign In and don't click Join Now, because that will mess things up. I will explain in just a minute, but you are going to be using your Google login, and so as such you actually kind of already have a Tinkercad account. Step 3 is log into Tinkercad with Google. So you will choose Sign In with Google. Don't make the mistake of clicking Students Join Your Class. You are actually going to sign in with Google first and then join your class. Step 4 is choose your Google account. So when you click Sign In with Google, it will pull up all the Google accounts that you have logged into on your computer. Please remember that your personal email will not work, and so you do need to choose your school Google email, the same one that you use to log into Google Classroom. Since you are already logged into Google Classroom, this should be very simple. Step 5 is join your class. This is a little bit detailed. You're going to find the profile button, and you're going to click that. That's the kind of head shape over on the right-hand side. You're going to then have a pop-up menu, and you're going to scroll down to the one that says Profile and click that. When you open the profile, you will see an option to click Enter Invitation Code. And your teacher will give you a code to enter here that is unique to your class. So you will enter that code, click Save These Changes, and then that logs you into Tinkercad and adds you to the class. Step 6 is click the Learn tab. So you will look here at the different options and you'll click on Learn. And from there, Learn will open up several options for learning how to tinker. Over the next few days, we're going to work on several of these. But for today, I want you to go to the Starters tab and complete all starter activities to learn about using Tinkercad. There are 7 of them. They take a couple of minutes each, so you should be able to knock this out easily in 15 to 20 minutes. Now, I do need to know that you completed this work. So in order to get credit for completing your digital worksheet, you do need to document your work by taking a screenshot of each starter activity when you have completed it. And so I want you to take a quick look at how to take a screenshot. I recommend using the snipping tool, and I have put a short summary of how to take a screenshot in the instructions in the digital worksheet. If you're still not sure, you can always go back to week 1's video and watch the video that gives you more detailed instructions about taking a screenshot. Once you have completed all 7 starters, you should have screenshots of each of them in your digital worksheet. You can paste or insert them, and then you can click Turn It In. I want to mention that our digital worksheet has some awesome links so that you can look at the capabilities of different 3D modeling software as well. So please be sure to click on those links and explore this topic a little bit more. Well, I hope you have fun learning how to use Tinkercad, and best of luck as you work on it today.